All right, so I want to talk a little bit about DNSSEC and DANE and some of the newer trends and newer things that are happening. But first, though, I want to just mention, I am with the Internet Society Deploy 360 program. How many of you have heard of us? Okay, a few hands. We are a program that was created 2 years ago by the Internet Society, looking at the fact that a lot of the technologies that the IETF was coming up with were not being rapidly deployed by the operator community. And so we were set up to say, what are the problems? Why aren't people deploying IPv6? Why aren't they deploying DNSSEC? Why aren't they deploying some of the routing technologies? What are the pain points? How can we find them? How can we fix them? What can we do? Our main work that we have been doing is with a web portal, which is at internetsociety.org/deploy360, where we have a variety of different resources. Some of those are tutorials, some of those are documents, some of those are pointers to other documents. A lot of material focused around IPv6, DNSSEC, and routing resiliency and security. And we have a number of pieces there. We're building more as the time goes on, as we get more of that. And in fact, out at the desk out there, we have a little sponsor desk against the back wall. There's a document which is a call for experts. We're looking for help from the community. You know, we are a nonprofit organization. We're focused on doing this out of the community, and we're looking for people who would be interested in writing documents for us that would be around any of these topics that I've talked about. We also travel out speaking to events such as this one. We have a series of conferences that we put on every year called our ICAN conferences. We just had one on Monday over in Krakow, Poland. I was just there, and we had sessions again about IPv6, DNSSEC, and routing resiliency. And then we have another one coming up later this year in November in Toronto. So we have a series of that. We're also, of course, very active in social media. Let me just talk a bit about DNSSEC for those who may not be fully aware. If we think about the normal interaction that we have with DNSSEC, or with DNS, just in general. When you're in your web browser and you type in a request for, in this case, example.com, your web browser is going to go out and, through the operating system, query for what's that IP address. And as you can see over on the far side there, I've got the typical iterative DNS process, right? If it doesn't have the answer cached locally, it goes out perhaps all the way to the root server to get the .com server, to get the example.com in this case, to eventually find out where is www.example.com. And then the DNS resolver gets that back, passes it to the web browser, which contacts the web server, and everything is nice and happy. Now, the challenge with this, of course, is that DNS operates on what? How does the DNS resolver know what answer to use? Anybody know? Speed, right? It's all about who gets the fastest answer back, what's there. So if an attacker is in the path, if the attacker can go and get a DNS packet back to the resolver quicker than the regular DNS servers are, the attacker can go in there and say, well, no, www.example.com is really at this address. The DNS resolver will pass it back to your web server, and your web server will go off to that site thinking that it has reached the correct site. It will go and do all of this like that. The problem, of course, is that the cache gets poisoned. That DNS resolver will hang on to that answer for some kind of time to live, a TTL, for some kind of time period. And that is the challenge that DNSSEC is aimed to solve. And this is happening out there. We're seeing various different reports and cases where this is occurring in a real live way. With DNSSEC adds some additional fields. There's, for the zone, in this case example.com, there's a DNS key, which is a public key. It's being used in here. There is also a RRSIG, which are signatures of the resource records that are there. So when you have the A records or the quad A's or whatever records you might have, they're signed, and this RRSIG is what is doing that. Then there's these other DS records that create this global chain of trust that makes it so that you can verify that, in fact, these records are the ones that you're getting out of DNS. The whole thing is to say, these are the records that I, or the DNS operator, I put in there. It's making sure that the records that somebody gets out of DNS are the same ones that you put in there as the person who's operating the DNS zone for that. So if an attacker tries to come in here, the attacker might succeed in getting to your DNS resolver first. But when a DNSSEC validating DNS resolver goes to look at that and validates the DNSSEC side, it will say, even if there's a signature in there, I mean, the attacker could be smart and try to spoof it with a signature and a DNS key. It will go back up this chain of trust and say, wrong key. Get out of here. Reject that result and pass back a server fail, which means that the web browser will know that it can't get to that web page, and it will display some kind of message. This is how DNSSEC works. This is how it all comes together. Now, there's two parts to this that I sort of already referred to. The one side is the signing side. It involves multiple parties. It involves a registry. The top-level domain, your TLD registry, has to support that, and .ua is a TLD that supports that, as is .ru, as is some others that are around there. You need a registrar that can support that, because the registrar has a role in passing this little record called the DS record, passing that back up to the TLD registry. And you need the DNS hosting provider or whoever is doing that to support DNSSEC and support the signing. On the validation side, it's a lot easier. You just have to enable DNSSEC validation in your DNS resolver. And any of the standard ones do. Bind, Unbound, Microsoft Windows Server, any of those that are providing validation servers, they all, at this point, can work with do DNSSEC validation. Now, one of the challenges on the signing side is it gets a little bit more complex because, as I said here, the domain name registrant, whoever has a domain name, somehow typically enables DNSSEC. Or some registrar, some DNS hosting providers just do this automatically. In some countries, like in Brazil, there's a company there that provides DNS hosting that just signs everything. Sweden, the same thing. There's a couple there that just do that. The DNS hosting provider, whoever's operating the zone, has to sign the zone and publish them. Now, one challenge here is that every time the zone changes, whenever you're updating the zone with new information in DNS, it has to be re-signed. And so it's a constant process of re-signing. So it's not just sign it once and be done with it. It's sign it whenever the zone file changes. So it has to be done in that space. Then, as I mentioned, the registrar takes what's called a DS record. It's a fingerprint of the key, and it passes that up to the top-level domain. And this is what makes this global chain of trust, which makes it so highly secure and provides this extra trust layer. A little challenge it gets into with all this is that sometimes registrars are also DNS hosting providers. It's common for many registrars to just do it all for you. Buy your domain here and we'll take care of it all. They'll do the hosting, and in the case of DNSSEC, they'll do the signing. There's a few registrars out there that have made it simple, trivial. Okay, there's one that I use that I can just go in and literally all I have to do is click a button. I check one box that says enable DNSSEC and I'm done. They take care of everything for me. They generate all the keys. They do all the passing up to the registrar. It's beautiful from a user perspective. It's simple. I just click the button and I'm done. But other registrars, don't. And in many cases, people want to operate their own DNS. They want to run their own DNS servers, or they want to use somebody else. I have a number of my domains. The actual operations are running on a DNS hosting provider that I like and that has rock-solid service. But then I have other registrars with whom those domains are actually registered, and I have to broker the connection, which unfortunately is mostly copy and paste through web interfaces, but we're hoping that'll change a bit on that. So that's kind of the signing side and the pieces there in DNSSEC. How many people have heard of DANE, other than the gentleman down in front? A few people. Okay. I want to talk about DANE because this is really one of the critical new things that DNSSEC provides, this capability that we have here. Okay. In a typical web interaction, if I'm thinking of going to a website that's secured by SSL, I'm going out and I'm doing my connection just through DNS as I normally am. I'm going out, I'm saying HTTPS, www.example.com, whatever it might be, and I'm getting back a SSL certificate. Yes, it's really called TLS, but the world knows it commercially as an SSL certificate, okay? But I'm getting back that certificate. That is what is enabling me to go and build my encrypted connection back to the web server. And I'm getting that nice little green lock, or whatever my signal is in most of my browsers. That tells me that, in theory, I have a secure encrypted connection to the device that's there. But is it encrypted with the right certificate? Are you sure that that is a certificate that the operator of the website wants you to have? Are you sure? Do you know? This is the challenge that DANE seeks to provide a way to solve, because you can get this. you can get a situation where you're going out and there is some kind of middle box. It could be a firewall. It could be an attacker. It could be somebody else who gets in the way and has some kind of mechanism to provide back to you a certificate that looks like it is the correct one. This could be the real domain. Now, the gentleman earlier who was talking about SSL certificates and CAs talked about the Komodo site, or DigiNotar, and a couple of the other instances where we've had valid certificates, valid SSL certificates, been issued to the wrong players. Somebody else has social engineered that. They've gone in there and they've, convinced somebody. Because here's the fundamental problem with the CA system. If you look in your browser, how many certificate authorities are inside your browser? Any guesses? Anybody looked lately? About 100. Okay, anybody else? I'll go with, it's about, I think, 60 to 100, somewhere in that range, depending on which browser, right? Because each browser has it. But each of those people, now guess what? Each of those certificate authorities can sell somebody a certificate for any domain. Okay? Any domain. You want one for google.com, you got to go convince your certificate authority to give it to you. Now, they're probably not going to do that, but if you can social engineer it or if you could take it over. And it's worse than that, actually, because there are resellers of certificates. Some estimates say there's about 1,500 different entities out there that can issue certificates in anybody's name. So you have this big challenge of trust that's out there. So somebody, an attacker or a firewall, there are out there some root signing certificates that you can get that are used in some instances where somebody could take this connection that comes back, re-sign it with the authority that it looks like it's coming from that site, and they could go and do things like log the data or do other pieces like that, inject something else. So this is the reality of SSL and TLS today. We can't entirely trust that we're using the correct certificate. Here's how DANE can help. What happens with DANE is that we use a new record called TLSA, okay, which is a TLS. It can be either an entire certificate. You could use a self-signed certificate, put it in DNS, and then you're encrypting it with DNSSEC to go and provide this extra security. Or it could be a fingerprint of an existing certificate. So you can say, using a fingerprint saying, this is the certificate that I want. So now when an attacker were to go and be in the middle here and provide back a certificate, the browser can do an additional check through DNS and DNSSEC and come back and say, well, wait a minute, that's the wrong SSL certificate. That's not the one that I would do, and can give a warning or some kind of, in some kind of form to let you know that this is not the correct thing. This would be what happens in a DANE-equipped web browser. So this is it. It's looking at how do we go and do this. So it is an RFC 6698. It was published about a year ago. It's called the DANE protocol. And this is what it does. It does a certificate or a fingerprint of that. And it can be and the beauty of this is it's controlled by whoever operates the DNS. So I can put in there, I can say, this is the certificate that I want people to use when they connect to my site. And again, it can be my expensive EVSSL certificate that I paid for with extra validation. Okay? And I can now have an additional trust layer saying, this is really the certificate I want. Or it could be a self-signed certificate, or it could be whatever else. Now, I've talked about it in web browsers, but it's not just for that. And in fact, for some reasons, the first implementations we see may not be for the web. Okay, because one challenge with the web browsers have pushed back at, first is that age-old thing of saying, nobody's asking for it. So we're not going to build in DANE support. So one of my requests today is, if you have any connections to web browser vendors or lists, ask for DANE. Okay? We need to have people asking the browser vendors, letting them know that we're interested in providing this extra layer of things. The other issue that they have is that, and I'm not entirely sure how we deal with this, is a lot of the web browser vendors right now are focused on speed. They want to have the fastest results for their browser versus the other browsers. And this extra check does introduce a small degree of latency. And so some of the people are pushing back. They're saying, I'm sorry, we can't do that yet because of the fact that it will increase speed. So we need to get this momentum building around people to say, we want this extra layer of trust in here. Now, in the meantime, other people are saying, well, let's go and look at how we can go and use DANE in other cases. Because if we could turn DNS into a publicly available user-controlled public key infrastructure. If we can have a PKI in DNS, let's use it for other stuff. What would we do if we have a PKI that I, as the domain owner, am in control of? What can I do? People are looking at now, how can you use it for email? How can I go and do things with Start TLS or with SMTP, with SMIME? People are looking at it in voice over IP, in the SIP protocol, and places like that. We need to have certificates that go out and are connected to the endpoint. The phones need to have those kind of connections. How do you broker that connection? How can you do that? DNS provides one mechanism for doing that. There's people who are looking at stuff with XMPP, Jabber. I'll give you, and this is in the slides that are up there. Here's some recent drafts that have come out within the Internet Engineering Task Force. A couple around email. One, how many people are aware of postfix for email? Okay, number of people in here. Okay, well, Victor, the author of that, went out and implemented DANE support inside of postfix. And in the process of doing so, he wrote up this draft that's up here that is called DANE Operational Guidance. And he and Wes Hardiger, Wes Hardiger are looking for operational guidance, looking to turn this into a best practices guide so that people can be able to gather, and this is for developers and other people who are implementing that kind of thing. So it's a document that's out there, and I encourage you to take a look at it. Again, another one for Dane at SIP. There's some people, Paul Wooters has brought out some drafts on how to use it with OpenPGP or also with OTRIM. So some good stuff out there that's happening in that line. So I want to briefly touch on some trends that are happening in the signing. This is a chart showing the top-level domains and the signing status as of earlier this month. And this is showing a lot of the world is signed. These are CCTLDs, in addition to all the generic top-level domains. Another thing that's happening, how many people have been following the expansion, the new GTLDs that ICAN is looking to all the new ones, .bank, .blog, .whatever? People following that? Okay, a few in here. Well, all of those new GTLDs, and there could be hundreds to thousands of them over time, all of them have to have DNSSEC as part of their operations. It's mandated. It's got to be there. It's part of their rollout. So all of those domains will be coming out with DNSSEC as part of that. Here in Europe, in the Eurasian region, again, much of your region is already signed, and that's the first step. The top-level domain has to be signed, and then below that, you need registrars and others. We're seeing a good deployment of second-level domains. Here's some charts showing .nl, .cz, .br, .se. You can see there's been a nice growth path in that. It's been happening. I don't remember the current percentage, but a little while ago, it was well over 20% or 25% of all the .nl domains were being signed in some way. .com saw a nice big jump in the past year or so. Now, this is still a tiny percentage of the .com domains, but it's a nice chart to see on that. The U.S. government is an entity that's been focused a lot on rolling out DNSSEC within its domains, and you can see here about 86% of the U.S. government domains are signed right now, and they're focusing around that. Now, on the commercial side, this is a chart that NIST maintains of the Fortune 1000 and some of the top signs. It's very small, and we're aiming to work on that as far as the large sites out there. But there's also a new statistics site I thought I'd mention. We have a number of them listed, but here's one called StatDNS, which provides some interesting stats that you may find useful on there. On the validation side, the people who are running validators, because you need this in order to have this work, one of the big things that happened this year was that Google, in their public DNS service, wound up turning on DNSSEC validation by default. So everybody out there who's using Google's public DNS servers is getting validation by default. And this turns out to be a significant number. I'll mention that in a minute. In North America, Comcast rolled out the DNSSEC validation for all of their 18 million customers. Sweden has almost all of their ISPs using that, and you'll see that on a chart. I'll show you in a moment. Jeff Houston out of Asia Pacific, APNIC, did some studies and found that we're up to almost 8.1% of all DNS queries that he was finding are now being validated. And a significant block of that is coming out of the fact that Google signed theirs. And there's a link on here for some more information. It's there. Google started validating, excuse me, not signing. They're validating that. Here I thought was an interesting chart. This was his measurement of the top 20 countries where he was seeing DNSSEC validation happening. And you can see Sweden's right up there with this middle column here, 77% or almost 78% of the sites of the queries they were seeing were all doing DNSSEC validation. You'll notice, I was pleased to see when I was putting this chart together, there at number 12 is the Ukraine. So kudos to the Ukraine for being up there in the top countries that are providing this extra layer of security through DNSSEC validation. So this is happening out there in that way. I'll mention to you all who are operators here, there's a great document put out by Surfnet, which is an entity out of the Netherlands, which is all about talking about how to deploy validating DNS resolvers. And they make it very simple. They go through and they talk about what you need to do, what you should be thinking about in setting this up, and they provide instructions for bind, unbound, and Windows Server. So it's a great document to go and look at. Some of the challenges that we have, if we think about what do we have to do to get more domains signed and more validation deployed, one of them turns out to, again, be this issue around registrars and DNS hosting providers. And it's something that we as the Internet Society, along with a collection of many other people in the industry, are looking at how do we help enable this? How do we encourage this to happen? There's several proposals in right now for some mechanisms where a DNS provider can add a field in that would alert a registrar when there's a new key that needs to be updated, or when there's a new record. There's some pieces like that that's there. So there's some work going on within the industry to go and try to make this more automated and to work better. We need to get more validating name servers out there. The one thing that's nice with Google turning that on has been that it's encouraged a lot of other people to look at this seriously and say, why not? It's also a great time, as one of my guests on my panel on Monday said, it's a great time to do it now before there's a huge expansion which is happening in the number of signed domains, because you can experiment, try it out now, get validation working so that it's not breaking sites that as we start to move on further and we get more deployment out there. It's a good time to be testing this. Enterprise signing, we're also seeing an increased amount of, or interest in doing more with DNSSEC from a government end. On the registrar side, one interesting thing is that registrars that want to be ICAN accredited, they want to be accredited with ICAN, they want to be listed in ICANN's list of registrars, they have to sign a registrar accreditation agreement. The new one that came out this year requires registrars that want to be accredited to provide a mechanism for DNSSEC records to be updated. So the registrars that are out there, if they want to do this, are going to have to implement DNSSEC. So this will solve one of the major challenges we've had in getting some of this work done through here. The actual specification, I'm not going to read it all, but it basically says customers must be able to relay key material through a registrar, a key step that we've seen. There is a public mailing list available. It's called DNSSEC-Coord. It's DNSSEC coordination. It's a list that any of you are welcome to join, where a number of us get together, discuss ways to accelerate the adoption of DNSSEC and to work with this. We also have some monthly conference calls. We do some other work around that, and we'd be delighted to have anybody else who's interested in helping us move this along and make it more of a reality. It's there. Let me just finish by saying there'll be a workshop happening at the ICAN 48 meeting in November in Buenos Aires, where we'll be having a series of presentations on these kind of topics. How can we further deploy DNSSEC? What are some of the new things that are happening at the operator level around automating this? What are some of the new APIs available? This is there. If you aren't going to Buenos Aires for ICAN 48, it will be streamed live. So you will be able to see it, and you can find more information. We'll have info up on our Deploy 360 site as it gets closer to the time. We have a set of documents on our site. If you go to our Deploy 360 portal, we have a series of documents. There's a basics page that goes through all of this type of information and provides some DANE ones. Again, I mentioned the Surfnet white paper. There's also a DNSSEC how-to, which is a lengthy document getting into both sides and really explaining in some strong detail about what this is. And lastly, of the many resources, there's just a new version that came out from the United States National Institutes of Standards and Technology, NIST. They call it their Secure DNS Deployment Guide. It's actually a fascinating document because it was designed for U.S. federal government agencies to help them understand how to deploy DNSSEC. But it's a great document for anybody. It's not specific. I mean, there's a few references for things that are related to the U.S. government, but for anybody, for an enterprise, for a network operator, for anybody, it's a great document that's really a tutorial around how to go and implement this. And it's a good piece of item like that. So, oops, I'm hitting the wrong button. There's also for those of you who are operators, Comcast put together a case study of the lessons they learned in the rollout that they did out to their 18 million customers that they did. And you can go to the URL, it's mentioned here on the screen. It was at the 45th ICAN meeting last year. And it was a great document really talking about what did they do as a network operator to provide this. Now, they did two things. They rolled out validation to all of their customers, and they also went off and signed something like 5,000 different domains that they had under their control. So it talks about both sides of that in there. There's a good number of DNSSEC tools that are coming out. And we have a list up there. There's also a DNSSEC Tools project that has some good tools that some of you may use. There's another project as well called Open DNSSEC, which works a lot with providing the ability to sign domains and work in that space. There's a great number of new things coming out with this. I mentioned before DANE. There's a series of resources that we have up on our site that are out there, and there's some RFCs that you can use. So I'd leave you with 3 requests. Please, if you can, look at how to go out there and deploy DNSSEC validating DNS resolvers. Those of you in Ukraine, you saw you were in the top 20 countries. Let's see if you can get bumped up even higher on there. Let's see if we can get more validation happening that's out here. If you can, look at how to sign your domains. It's a bootstrapping issue that we need both happening, and we're getting both to happen, but I would encourage you to do that. And third, I would ask you, look into what this DANE is all about. Look at how you can promote it, how you can help people to understand what it is, and where we can go from there. Finally, the Internet Society Deploy 360 program is a program of the Internet Society which is aimed to provide you resources and to provide you material to help you get started with these technologies. And we'd, please visit there, look at the material. If there's things you can't find, let us know, because we're glad to help promote those. And also, if you see some really good materials, let us know that too. Because we're always looking we don't want to create everything. We're looking to point to other materials. Just recently, we pointed to some excellent tutorials that the RIPE NCC put up, and the training materials about how to migrate to IPv6. If you see something really good that helps you, let us know that too, because we may not necessarily have seen it all and found it all out there. We're also looking to talk to people and talk to you about case studies as you go and do this. So I'll say spasibo and open it up for questions.
Actually, I'm sorry, but we have some questions from the online, from the Jabba. I can say it in Russian. Maybe it will be translated for you. В последнее время в РФ в соответствии с законодательством необходимо блокировать сайты. Многие операторы блокируют с помощью подделки DNS. Если сайт имеет DNSSEC, то пользователь узнает об этом, но чем это ему может помочь? То есть, да, домен подделан, но что будет делать, что делать обычному человеку дальше? Is it have translated or can?
Perfect timing. My battery seems to have died on this.
Okay. Recently popular idea of blocking of sites under the laws of the Russian Federation with the help of the fake of the INS records. If the domain with DNSSEC and the user will know, but the site will be not available. That is, the user sees that the domain is tampered with, but he doesn't know quite help. Why do you think about this? What do you think about this?
Sure.
How to help users to understand what we can do with this?
Sure. So basically, if the site is being blocked, right, and using DNS to hijack that, DNSSEC would be able to say to somebody that they are not reaching the site that they're supposed to be getting. DNS would tell them to get one site. The information that they would get back would say that the IP addresses are this, which would have been the redirected IP addresses. And they would look at that and be able to say, well, there's something wrong here. So the browser would know that they could not get to the site. Oh, thank you very much. They would not get to the site, so they would know there was a problem there. Unfortunately, the DNSSEC, that's what DNSSEC can do. DNSSEC can let them know they're not getting to the correct site or the correct addresses. In the case where something's blocked like that, they're going to see a visual sign. I mean, it'll be broken, it'll be blocked in some way. So at that point, DNSSEC doesn't necessarily help them too much because it's being filtered out by somebody. The case that's probably more a place where DNSSEC could help would be if somebody had maliciously injected a different site, or if the government in there was mirroring the site or doing something or passing it through and providing some level of filtering. If they were going and if you were interacting with some kind of site and there was somebody else in the way, a middle box that was taking all of your information and logging it, DNSSEC could help you know that box was there and prevent you from having that interaction that was there. But that's about the level I think it can go to.
That is a continuation of the question. Is it possible to, for application somehow to say the maybe abuse list or something like this, that, okay, in this territory, your site have another key or have some informal activities? Is it some kind of this approach? It can be.
Well, so I mean, DNS is global, so you're going to see the results coming out of the global DNS tree, and the keys all go up to the global root. So you're gonna, I mean, the beauty of DNSSEC in that case is that it is ensuring that you're not getting something that's signed that's elsewhere on that.
Yes, I'm talking about informing the resource owner that something going wrong with your site on this territory.
Well, so interesting idea. I suppose you could create a tool that would do it.
Maybe it is a good idea to use RIPE Atlas for this.
Well, yeah, I was thinking, RIPE Atlas would be one way to, a measurement item like that would be a good way to go and do that. Maybe the RIPE Atlas folks could put that in their list of a zillion ideas I'm sure that they have.
So just add to Atlas probe some kind of test that if for this particular test or just observing the internet for another probes, they found DNSSEC failed resolve, just to publish list of the places where it occurs.
That's actually a good point. There is actually a couple of efforts out there where people have been posting domains that have failed validation, but they're doing it at a top level. Like, for instance, one of the things was Comcast's DNS team they have a Twitter account, which is just domains failing validation. They post those out there, more to let people know that this is going on. So if somebody misses a key rollover, they do something like that, that's out there. But certainly somebody could do that. It's an interesting idea to think about using the Atlas probes or something like that to do. Actually, we'd love to chat with the folks about that because it might be interesting to enable some of that so we could see some good measurements around DNSSEC validation. It's kind of hard to do that right now, to measure validation, because you have to go and do it. Jeff Houston at APNIC and his team have done some interesting things using little flash applets, flash ads in web browsers, and looking at getting kind of a global distribution of that and being able to then measure validation. But we need some more validation measurement techniques. Yes?
Okay.
Thank you for your presentation. I think that one of the problems with actually deployment of DANE, we have now ready-to-use standard. We have all the tools need to sign it. It's pretty simple operation, much easier, for example, than DNSSEC itself. The problem is that support in browsers is minimal, and actually it exists, but a set of patches. Different patches are on very different level of like readiness, stability, etc. So maybe it's a good idea for your group, of course, if you do have enough resources, to provide some ready-to-use packages, for example, pre-compiled installation of Firefox for users who would like to test. Because now most of these extensions are proof of concept, and they can work, but they most likely they will not. So
Funny you should ask that, because I realized as I was looking at my tools slide that I forgot to mention one thing. The folks at the DNSSEC Tools project, which I mentioned there, dnssec-tools.org, came out with a version of Firefox that they went through and they modified all the code to do DNSSEC validation and to do DANE support. It's called Bloodhound.
yeah, I heard about it, but I didn't
Yep.
found ready-to-use builds for all platforms, etc. Maybe I was looking bad, but
Well, they moved around their web page a bit to make it a little easier to find. So if you haven't looked in a bit, you may want to check back there. But if you don't, if you have a challenge finding it still, drop me an email, just york@isoc.org, and I'll help you with that. But they did create this primarily for people who wanted to do DANE testing. Just like we put up on our Deploy 360 site, we put up a list of sites that are out there that fail DANE validation for testing purposes. And there's a number of people who have operated ones with bad certificates or with bad signatures and things like that. So we've got those out there. But yes, Bloodhound is a good browser to go and do that.
yeah. And just a small addition about the question with national authorities who are hijacking DNS to block some websites. Actually, it's not a DNSSEC task, from my at least point of view, to report such problems. DNSSEC should resolve name to IP address if all chain passed, if validation passed, and not resolve if it's not. So yes, we can add some extended support to browsers, blah, 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 but actually the main thing is just to make sure that user will not be able to connect to the site at all. And
Right,
so
yeah.
I think that this question was trying to to resolve actually issue with the wrong tools.
Right. I mean, like I said, DNSSEC it makes it sure that you're getting the info out of DNS that you wanted to have in there. But that's it. Yeah, right. I see another question over here.
Actually, we're running on time. Sorry, maybe last question. Okay.
Okay. My question is related to previous speaker. It's about chain of trustness. If an attacker, if possible, is able to hijack and or spoof all chain, like big attacker like government with a Great Wall, firewall, and he can track and change the whole chain in theory. If the NSSEC allow us to detect such situation and see that we are visiting, what the whole chain is changed.
Well, it would be extremely hard for them to do the whole chain because they'd have to. This notion of this DS record that was that's in there that goes from one to the other, goes all the way back up to the root of the DNS, which is operated by a series of companies and organizations that maintain the top root. So somebody in order to compromise that would really have to get all the way back up to the top, and I don't know how they do that, quite honestly.
But according to recent reports, and by now, a government now is able to process and almost all traffic, and I think we quite able to do with it anything.
So they could, somebody could, I suppose, compromise up to the TLD level. But to get up to the root, they'd have to basically be in the way and present an alternative route. They would have to run an alternative route, essentially.
All traffic passes just one router.
Yep, but the way that
what can prevent them to change?
Okay, sure. What prevents them is that there are trust anchors that are available that are part of the systems that are validating resolvers that link up to the trust anchor at the very top root. If somebody were to go and provide an alternative route for DNS to resolve to, then what would happen is they would not have the trust anchor that was up at the root side, and so the final link in the chain of trust out to the root would fail. And so the full chain of trust would not do that. Now, somebody could modify the DNS validating resolvers and create different, additional. It's feasible that somebody could go out there and do it, but they'd have to really make a lot of modifications and compromise a lot of systems out there and a lot of, seriously protected systems in order to go and make that happen. So,
I see, thank you.
okay. Well, thank you again. My email address, again, is york@isoc.org. Please visit us at Deploy 360, and we would be glad to look at how we can help you out. Thank you.
Thank you, Dan, for a good presentation.